Hello dear learners and welcome to the week 10 of NPTEL course in pharmacognosy and phytochemistry. We started our course with definition of pharmacognosy and phytochemistry. Thereafter we learned different classes of phytoconstituents every week. Now in this week as well as in the forthcoming week, we will try to understand the methods for quality control of this herbal material. So before we go to that, what we studied in the previous sessions are different examples of drugs which contain different set of secondary metabolites which are often referred to as phytoconstituents. Now depending upon this phytoconstituents, they had different applications. Now once depending upon the applications, the herbal drug industry starts converting these plants into medicinal products. Some of them call it as herbs, some of them call it as herbal medicine, some of them are called as herbal medicinal products. Lot of these terms are used synonymously as well as amongst common man in the herbal drug industry. So when I have to communicate to you, I'll say that let me give you that herbal drug sample or let me give you that herbal medicine. So what exactly do I mean? Let's first try to understand this terminologies and then we will go into the quality control methods. So when I refer to or when I call as herbal substance is any product which is made up of plant parts. So when I say Vasaka leaf, that means it's a plant part, that is it's the leaf of Adhatoda Vasaka. When I say it is acacia, it is a gum, that means it is a gum which is obtained by making incision from your acacia plant. So herbal substances are actually products which are obtained from the plants, which includes the organized drugs as well as unorganized drugs. The organized drugs include plant parts such as fruits, stems, leaves and different parts which are not mentioned herein, like flowers, pollens, or in some cases even fruits and seeds, as well as your unorganized drugs, chiefly untreated exudates, that is your gums, mucilages, resin, etc. A few examples of such herbal substances are your Vasaka leaf, acacia gum, opium latex and so on. The next terminology is herbal preparation. Now this is when you take your herbal substance and process it further by applying numerous processes. Now this processes can be a simple extraction, like you prepare your tea. You take your tea powder and boil it, that's called as your tea extract. So you can do an extraction, you can do a distillation, you can do a fractionation, you could run a column chromatography and do a purification, or you can take the drug and do something called as fermentation. Now all this processing takes your herbals or herbal substances a step forward into making them a good product. Such preparations or such products are often referred to as herbal preparation. So herbal substances are native substance that you obtain directly from nature, whereas herbal preparations are the one where your mankind is involved in processing it, either extracting, distilling or converting into something. Say for example your Jatamansi oil, you are going to take Jatamansi root and distill off the oil, or papaya leaf extract, you are going to take the papaya leaf, you are going to juice it and thereafter you are going to dry it. That is, there is a human element being involved and such ingredients in market are referred to as herbal preparations. Now we go to the next definition. The next definition is herbal medicine or herbal medicinal products. These are products that you actually see on the counter, look like your allopathic medicine. Now take for example, here I have your Senna tablets. Senna, as we studied, contains anthraquinone glycosides and those are used as laxatives. Now convert them into tablets by using binding agents, disintegrants. That is, I take a drug, I add excipients and I formulate it in a way that it is very consumer friendly and can be used directly. In that case, I refer to my product as herbal medicinal product. So those are finished, well labeled, over-the-counter products, which may include simple substances, that is your herbal substances. So even you can have your shatavari powder, but imagine in a container which is ready for consumer use, that I can consume my shatavari powder from it directly. It is well labeled, how is it to be stored, how is it to be kept. Such cases or such products are referred to as herbal medicine. So it includes all your aerial parts as well as underground parts. You can take the drug or drug combinations, like your Triphala Churna is a combination of 3 fruits. Or you can have them in crude state. You can have your acacia powder, which is to be taken, or isabgol powder, or you can have a preparation which is being made, like we saw, the oils or blends. Now this also includes a lot of unorganized drug material, which includes your juices, gums, fatty oils, essential oil and other substances. They often contain excipients to make it consumer friendly and are in a state which is ready to administer. A good example of this include your Triphala Churna, Ashwagandha powder, as you can say your Senna tablets as well. Okay. Now with this we go on to our next important term, and that is botanical reference standard. Now we say that whenever you purchase a drug from market, you have to know what it is. Say for example, if I go to purchase an new vegetable from the market, I should have a predetermined notion of what exactly I am buying, otherwise I may purchase something else. So your herbal drug industry is very huge. There are numerous herbal drug substances which are official in different form of traditional medicine. So we have our Ayurvedic, we have our Siddha, we have our Unani, we have our folklore medicine, and in such cases if you just put together, there are thousands of herbs. And in some cases it's humanly not possible to know thousands of herbs just by visually looking at it. In that case, there are substances which the industry keeps for record, that tomorrow if I have to purchase this, it should look like this. Such substances are called as botanical reference standard. So imagine you going to purchase an orange, before that your parents show you, this orange in the market should look something like this. Specifically or exactly that the herbal industry does it. They give us what are called as botanical reference standards. These are reference standard of the most ideal drug, what your sample should look like. So this botanical samples or botanical reference standards help us ensure identity, they help us ensure purity as well as the composition, which are very vital for the quality. Now whenever an industry is keeping a botanical reference standard, that is a standard which is well characterized. That means if I am showing you an orange, before I tell you to get orange from the market, I myself will make it sure that this is the genuine orange. How do I do that? I do some evaluation which includes your physical, chemical, maybe DNA, genetic, I'll see some molecular characteristic, and everything of that is validated. So you can see a botanical reference standard in the image here, that's of Calendula officinalis, which is used as an anti-inflammatory drug, which is often there in many of your anti-inflammatory balms or lotions. Here in this case it is DNA barcoded. What does that mean? That means even the genetic makeup of that botanical reference standard has been tested for identity. So only when the DNA matches, I am telling you that this is the orange what I want. So this is the calendula that industry wants for its use in herbal preparation. So botanical reference standards are associated with different parameters which will help us assure the quality. So once you get a orange from the market, now I will compare and I will come to know how genuine it is, and that's what your botanical reference standards are for. Similar to that, we have another set of standards which are called as phytochemical reference standard. So far in every chapter we've been studying different classes of phytochemicals. Now this phytochemicals may be your alkaloids, glycosides, tannins and so on. Now what happens is every drug contains some of them in a unique way, some of them in a synonymous way. Now say for example, when I am telling gallic acid, there will be many drugs containing gallic acid. But if I say meconic acid or tropane alkaloids, there will be few plants which will be containing tropane alkaloids. So they are what are called as markers. So this marker compounds are often used to analyze. Now here what we have an example is a very simple example, and that's your turmeric. So in your turmeric you have your pigments which are your yellow pigments, and this yellow pigments are curcuminoids. Okay, so curcuminoids are mixture of three pigments we saw, and chief, the major one among them is your curcumin, the structure of which is drawn here. Okay, so this is curcumin, and if you recollect, when you remove this methoxy you get a dimethoxycurcumin. When you remove both of this methoxy, you get what is called as bis-dimethoxycurcumin. So this mixture of three pigments is very much characteristic of curcuma longa or turmeric plants. Now if I have to standardize that, what will be my reference standard of this pigments? Your curcumin is the major one. So of these three pigments in terms of composition, as you can see here even in the TLC, your curcumin, you have your dimethoxycurcumin, and then you have your bis-dimethoxycurcumin, of which the major one is your curcumin. So this I will use as my reference standard. But in order to get that as a reference standard, I have to have something to compare with, and that compounds are called as phytochemical reference standards. So industries often will purchase, procure or purify and keep this curcumin, and this curcumin will serve as standard. So every time they get a new turmeric sample, they are going to run a TLC, they are going to spot your curcumin here, and they are going to run the turmeric extract here. So what you get in the process is you will be able to see is it a genuine turmeric or not. So they help us not only to check the genuineness, that is the identity, they also help us to quantify. So if we subject to analytical methods such as your colorimetric estimation, say for example I have my standard curcumin, and 10 microgram of curcumin gives me an absorbance of 0.5. Now if I check my turmeric extract, and again I will get a same kind of absorbance values, say for example 0.5, then I will say that my turmeric extract also contains 10 microgram per ml. So I can also know the concentration, I can quantify it by UV, I can quantify it by TLC, that is specifically HPTLC, I can quantify it by HPLC, UPLC and so on. So not only this phytochemical reference standards help in identification, they help in quantification. So tomorrow I have a bad sample. So normally if you see the curcumin content goes between like 2 to 7%. So if I have a bad sample which just has 1% curcumin, I can reject the drug. Or if I have a really good sample which has a curcumin content of 7%, I know that is the one I have to purchase because it's a good quality one. So they help you in having product consistency also. One batch has 7%, another batch of turmeric rhizome has 2%, another batch has 3%. So that will lead to huge variation in my product. So this determinations or this phytochemical reference standards help me in analysis and thereafter help me maintain the consistency of my product. Now we move on to quality control. What exactly is quality control? Quality control is a method which I will do or which I will carry out to check whatever is given to me, does it match to the description of that. So if you tell me you want to get a tulsi leaf, so is it really a tulsi leaf that you are giving to me? What all I can do to check that is a genuine tulsi leaf, I will call all those things as quality control methods. So we have World Health Organization, and World Health Organization defines the term quality control as sum of all procedures, whatever you can do, sum of all procedures that are undertaken to ensure that the identity and the purity of particular pharmaceutical is there. So say for example we just refer to our tulsi, so identity, is it the genuine tulsi I am looking for, and purity. So if I have 1 kg, is it all 1 kg of tulsi leaves or it is 800 gram tulsi leaves and 200 gram something else. So quality control are all the methods that we will carry out to ensure the identity, purity, and when we say purity we also refer to as content. Now why is that important? These three components once ensured at the entry level itself will help us gain the quality product. Now entry level means right from the farming stage. So you have to maintain a good quality of your plant to get your good quality product, and then once all of this are ascertained in terms of my raw material is good, then my product is definitely going to be good. So quality control methods are methods to ensure your identity, content as well as purity of the drug substance. Now why there is a need for quality control? The need for quality control is basically of three principles. The very first principle is consistency. See, when I am doing an allopathic preparation such as aspirin or paracetamol, when I am preparing a 500 mg tablet, I know that tablet is bound to contain 500 mg of paracetamol, excipients apart. Now what happens in plants is, if I am not able to match up that, I cannot say that my amla every time is going to contain 1% gallic acid. The consistency of my product changes. So quality control will ensure that my consistency of product remains. Whatever I consume should be safe. Safe because if I consume something which is unsafe, that is going to be detrimental to the health of my patient. And next, efficacious. Now most of the preparations or herbal preparations people just take because they are safe. Very rarely people say that I take this herb because it is more efficacious as compared to allopathic. We hardly find such definitions. I put the efficacy last, but it's not the last. That's a very important part. Your drug should be efficacious. When you ensure consistency, when you ensure safety, when you ensure the content of your phytochemical is good, it will show you the therapeutic effect. That means it is going to be efficacious. This efficacy is seen by testing it on animal models, humans as well as on the cell cultures. Okay. Now let's dwell little deep into this quality control parameters. So what is consistency? For consistency, I have to ensure that whatever raw material I am receiving in my industry is authentic. When I say authentic, that means it should be genuine. What I asked for is orange and what I get is an orange. Okay. So now authenticity is very vital because that will give me the remaining two, that is your safety and efficacy. Now when the drugs are not authentic, that may be due to adulteration. What is adulteration? Adulteration is when you intentionally or unintentionally add something more. Say for example, you add your brick powder to your chili powder. That is a classic case of adulteration. Or maybe you must have come across for your turmeric itself, people add dyes such as methanol yellow so that that haldi looks more intense yellow in color. So that is what is called as adulteration. Substitution is I replace it, I substitute for it. Okay. So imagine I have chandan ka wood, but instead of chandan ka wood I am selling it something else. That is, I am selling a plain cedar wood or some other cheap quality wood. I substitute it, and that is very bad. The last case is spurious. Spurious is, you might have come across many spurious products in market. Spurious is, I am giving you something, I'll say that probably this is a product which Himalaya has made and this is very good, and actually it so happens that either this company which has prepared doesn't exist, either the product is misleading. I tell you it's an ashwagandha powder, but actually it is something else, and what happens is this all are labeled as your spurious. So when I'm doing quality control, I have to ensure that I have to have an authentic drug which is free of any adulteration, substitution, which should not be spurious in terms of product. Now consistency can also vary due to content variation. Now this is something which is unintentional. Like I said, say for example, when I am talking about amla, I require 1% of gallic acid in it. Now, in some cases, I might get a batch of raw material of amla powder which might not have 1% of gallic acid. Now, the reasons for that could be basically categorized into two parts: intrinsic factors and extrinsic factors. Now, intrinsic factors are more to do with the plants. Imagine you have a huge farm of amla, but due to certain disease, certain infestation, some mutations happen, or your farm has been there for ages and now it is all grown old, and the plants are no longer as vigor or as with vigor as they were previously. The content of your actives goes low, and that's where when in pharmacognosy, when we were saying acacia, we said that better you tap it between 6 to 8 years of age. Beyond 8 years the gum is not as good. Or when you're even taking out gum, just see that first few tappings are good, later on the quality of the tapping becomes weak. So what happens is, due to age, due to disease conditions, mutation, a lot of other factors, the plant itself will secrete less amount of gallic acid. That is also leading to your content variation, and that will change the consistency of my product. Similarly, sometimes the factors are not in plant but they are in the external environment. This includes climate. Imagine too much of rainfall or too little of rainfall, the soil, sometimes it is conducive, sometimes it doesn't have any humus, minerals or any support nutrients, and as a result the yield of your metabolites will fall less. Presence of other crops which kind of eat up the nutrition and then they will harm it. And if you're not replenishing the ground, you're kind of using the same field over the period of years, suddenly what has happened is all the nutrient of that particular plot has gone in, and that will lead to decrease in yield. So your consistency of the product will vary, and these are few factors for which it will vary. Another reason or another way to see quality control is to ensure safety. And safety, when I say, I have to be safe or I have to keep my product safe. Now this product certain times intentionally or unintentionally contain hazardous substances. Now this hazardous substances can include pesticides. We are very cautious about having or seeing pesticides in our food, drink, but imagine that can happen in your medicine as well if your medicine is a herbal product. Just to protect it from infestation, the farmer might have sprayed pesticide, and what happens is during the course of processing, this pesticide will get concentrated and it will end up in your medicinal product. Similarly, if you have plots or farms in places where radioactive substance have been mined or radioactivity is being used, there are good chances that this substance will also carry some residual radioactivity. That is not at all desired and that is harmful for our health. Previously, we also seen aflatoxins as fungal metabolites from Aspergillus. They cause food poisoning and you remember liver cirrhosis and cancer. So a fungal infestation that could lead to deposition of aflatoxins is something that we don't want in our product in order to ensure safety. Similarly, we don't want any pathogenic contamination. See, we don't eat our products or we don't eat our drugs in the more sterile form. We don't sterilize our food and consume, right? Similarly, our drugs need not be sterile if you are taking it by oral route. But it is necessary to ensure that the microbial load is minimum. It is necessary to ensure that there are absolutely no pathogenic microorganisms which can cause disease to us. So we also check or ensure that the microbial contamination is minimum as well as the pathogenic organisms are not there. Apart from that, it should be free from foreign organic matter. This includes, other plant parts, animal excreta. There are certain cockroaches in your products. We don't want that. All those animals, animal products, some flies which have infested the drug and those wings are all fallen off. Those are all treated as foreign organic matter, and these parts or their metabolites or whatever comes out of them may be a health hazard to us. So in order to ensure safety, we should see that this hazardous substances such as pesticides, radioactive contamination, aflatoxins, microbial contaminations, foreign organic matter, or even for that matter inorganic matter such as soil should not be there in our product. Efficacy, we know that whatever you consume, if it is potent, only then it will work, and that's why even efficacy studies need to be done. Now for which, how do you do quality control? Now there are certain guidelines or certain reference books we often refer to for quality control. Now this quality control is being governed and regulated in different countries by different guidelines. The most common ones or most common followed are your pharmacopoeias. So every country will draft their own pharmacopoeia, the official book. So for India, we have our Indian pharmacopoeia. For America, they have US pharmacopoeia. For Europe or for England, they have your British pharmacopoeia, and so on. So every country will have its own pharmacopoeia. They will lay the guidelines. If Vasaka is to be there, this has to be the quality parameters for Vasaka. Similarly, for taking into consideration the developing countries, WHO also came forward, and WHO laid down guidelines which are kind of minimum benchmark. That means your compounds or your drug substances should at least adhere to this, and then that is included in the WHO monographs of this herbal substances as well as WHO quality control methods. Now Indian Council of Medical Research has also come out with its own version of herbal monographs to ensure the safety, and they also contain detailed quality control procedures. So with this, in the next session we'll go on to more deeper into methodologies, but here are a few references if you wish to know why we should do quality control, and thank you everyone for your patient listening.